here's how I'd like the program to run. Enter number, radius, whatever. Do something with that number. Do you wish to repeat? Oh yeah. Enter number. Good, it's recording, but the mic's not cranked up. Alrighty, can you hear me now? Alright. Do you wish to repeat? Yeah. Enter a number. Okay. I'm tired of it. Quit. So when we did some flow charting, process calls looked like this. What I'm going to do, and you don't necessarily have to flow chart it with me, because I'm going to post the results, upload it. It's going to be a flow chart cheat sheet. You can look at it during the exam. If I say, what kind of question do you use for print? You can use the cheat sheet. Or better yet, you memorize it. But, you know. And if you feel like drawing along, that's fine. But I'm going to go at a pace where I'm not entirely expecting you to have done so. So just be your own judge there. So we need Terminators. I should have asked, what do you start and stop your flowchart with? But I didn't. So anyways, Terminators. Two kinds. If it's your main code, you use start and stop. However, we also did functions. Modules. So instead of start and stop, this starts with a module name, which I like to use DEF for. Don't believe the book puts the word DEF there. And then the bottom of it is return. So typically your code will have both. It'll have a main section, and if there are any modules in it, it'll have, you know, another column starting with that and stopping with that for each module, each function in your code. So what kind of blocks do we put input and output in? Yeah, the tilted. The data blocks. So that's for I/O. Input. Output. And traditionally all these things are supposed to go top down. The only time you have something going back up is if it's a loop or if you hit the bottom of the page and you want to go back to the top. But on this program it's easy to just make it go multiple pages. Nothing wrong with that. So these are for I/O, input output. Really there's not two forms of that, unlike this. So math statements and other functional things like that go in process blocks. Math calculations, assignments, declarations. You can put all your declarations if you want. That's how the book shows it. So that's the process block. Now typically you don't want to put a whole bunch of things in a single block. If you're asking somebody for both their weight and their height, I wouldn't do input, weight, and height in a single input box. Unless you were absolutely sure that they were going to type them both in on one line. Yeah. If you have a web form, you know, and it's getting data from the user and it's got both their name and their address and, you know, their phone number and stuff like that, you don't need to list 4 different input boxes. Get, you know, first name, get last name, get address, get phone number. But we're not doing web forms or anything like that. We're just doing text entry, so we typically want just one thing. Same for math calculations. Those really ought to go 1 per block. You shouldn't stick a whole bunch of stuff in a single block. If you were going to do that, instead you would make it a module. The only one that you can put modules, you can put multiple declarations. in a single block if you want. Alrighty, then there are the decisions. How much have we talked about if? Have we done if statements yet?
Start talking about it.
All right, so those are decisions. If. There are two kinds of ifs, really. It's the same shape. The book doesn't even show putting the word if in the block. They just put the condition. So like they'll do if, instead of doing if A is less than 10, they'll just say A is less than 10. I strongly recommend putting the word if in there because it makes it easier to read. The other reason why I recommend doing that is the decision diamond is used for something else called a while loop. And I like to distinguish them. But you don't have to put the word there. But anyways, there are ifs and then there are if-elses. How do you distinguish the two? Just by the way things jut from them. If it's an if statement, the true condition runs off to the side, it does something, and then it comes back down here and they meet again. And it's kind of easy to make them meet again if you use a little connector. But you can get rid of that A if you want because it's just a connector. It has no importance in that. That's an if. You know, come in, you have a question. If that condition is true, you do a block of code, else you don't do anything. So if the user enters a negative weight, you can print an error message. You really don't weigh negative 10 pounds. If else means that if the condition is true, you do one thing, else you do another. So jutting off to the side of the yes, you do thing one. If the block is positive, if it's not, you do thing two. And I will tidy this up. I'm just not taking a lot of time, because time is of the essence, to make it pretty. And then both of those join back up together in a connector. And of course, everything will be coming, top down like that. So that's the decision block. The decision block can be used for ifs. It can also be used for whiles, which I will illustrate in just a minute. And again, the book doesn't put those words if and while. They just put the condition, but I think it's more precise. I think it's much easier to read. So these are decision blocks. Now we haven't done process blocks here, but I think we did a process flowchart already. A process call is a special kind of process block. The book shows it with a horizontal bar. The flowchart uses a vertical bar. But we're smart enough to remember that they're one and the same. Just you looking at the book, it shows one thing. So this is a predefined process. And it's a module call, also known as a function call. Book calls them modules. We call them functions in the programming language. We just have to get used to the fact that in programming discipline, different people use different words. For example, functions are called methods in some language and subroutines in another. So anyways, and procedures in another. Nobody wants to agree on the same term. So there we go. I believe that's all except for the while loop. I have not illustrated the while loop yet. Conceptually, the while loop looks like this. It's got some setup above, something's happening to it, going into the, and then it'll have a condition, while A is less than 10. So for example, if we had a process block that set it up with a declaration that said A is equal to 0, 1, whatever. If A is less than 10, or while A is less than 10, go over here and do something. Looks like the if, right? But the difference is that when it's done doing something, it loops back to the diamond. Now, every previous semester I showed it looping like that. But we have a new textbook, a new sheriff in town, so they show it doing that, coming back up to the side like that. This do something, it better modify the value of A. Because if it doesn't, if A was less than 10 to begin with, it's going to repeat infinitely. That's called an infinite loop. There's a way out of an infinite loop if you use what's known as a break statement, but I'm not going to flowchart a break statement. I'm going to try to avoid them. And if once this is no longer true, or if it was never true to begin with, it falls through. Just like that one form of the if statement, right? Over here, I'm going to delete that line, like that. You come in, if it's true, you do something. If it's not true, you don't do anything. Then you go down and you know, whatever the next step of the process is. Here, I'm going to take the word else out of there. If this is true, yes, do something. If it's not, do something else before the pathways converge. So let's get idle open, just to keep us on our toes, and type an example of an if, and an if, else, and then a while. When did I schedule our exam for? I might conceivably want to push it back a day, but I didn't want to put it on the last day before spring break. I may make y'all suffer along those lines.
Pretty sure you said on the 8th was when we were going to have the exam.
I want to move it to the 13th if that's okay with y'all. Sure. Anybody not going to be here on the 13th? That'll give us another day. It'll catch y'all up pretty much to the other class. Then I can slow down a little bit today, because this is important stuff. I don't want to go nuts on us. So launch idle. I know you already have. I thought I had too, but I don't see it. Alrighty, fine. Remember to dock it. Alrighty. Pin to taskbar. Pin to start menu. Now I'm happy. Now I know where idle is. So I'm going to do a file new. Name, date, decision, which are if else, and while. There are other kinds of loops besides while. There's one more form of if. There's another kind of loop called for. We're not going to hit all those because we want to hammer in the basics, and then the others are kind of frippery. All right, so we need some data to play with. We could ask the user for it. Why not? Age is equal to input. What is your age? We have to convert it, so age is equal to float age. No, I'm sorry, I put that in quotes. That was wrong. Do not start putting the quotes there where I put that there. You use the quotes for input because that's a string. But if we did that, it would be trying to convert the word age to a number. Age isn't a number, so that wouldn't work. Instead, we wanted to use the variable. Okay, so we have an age we can play with. Let's use an if statement. If age is less than 0, print no way. We know that's not true. If age is greater than or equal to 18, print eligible for the service. Now, I believe some services will take you to 17 with parents' permission or something like that, but anyways. But we want to do an else. Print. Come back next year. I'm thinking the font size either needs to be bumped up one more or the lights need to be doused one. Perhaps both. All right. If y'all can't see in the back, wave your hands. Because I know that, double quotes and asterisks and things like that start being hard to see. So go ahead and run it. Don't wait for me to run it. That's not code that it can run. So do a save as. Do not save into the root Python directory. I've had people texting me say that Python stopped working on their laptop, and we haven't necessarily been able to figure out why, but in previous semesters it's usually because somebody saved it into the Python directories instead of moving out of there and putting it in their own directory. Honestly, those directories probably ought to be protected, read only or whatever, but they're not. So. All right, I'm going to run it. What is my age? I'm going to test both conditions. March1.py. What is my age? First, I'm going to find out what happens if I'm too young. Come back next year. Now, I said both conditions, but there are really three conditions, right? Because if it's less than 0, prints no way. Let's do it again. I want to be old enough for the service, so I'm going to type in 18. Make sure that works. That 18 is a boundary condition, so it's worth testing both sides of it. Called an edge case. Edge cases are, right where the logic is supposed to, differentiate. And let's try age less than 0. No way, come back next year. Wait. Okay, so that's true. It wasn't what I was expecting, right? Because I was expecting this to be an error message. And if that happened to not do this stuff, but that's not the way I worded it. So, and I'm not going to take the time to try to figure that out. But I am going to change the no way. No way, invalid data. The way I would fix it, I'm going to demonstrate it to you, but then I'm going to delete it. Is you would change this to what's known as an else if. But this language doesn't support the word else if, instead it's just elif. Means else if. If I ever say else if, it means that I've forgotten that I'm working in Python, that I was treating it like C++ or JavaScript or, whatever. So, changing this back to just a mere if. All right. We have the idea. This is that first form that I diagrammed. I'm going to add a print. Moving right along. This is going to be dumb. Nah, I'm going to leave that there. But you have the idea. Once you get to this point, you're done with that if statement. Just like over here, we could be cruising in to our code. Excuse me while I draw something and then delete it. I just want that arrow there. All right, so you're cruising into your if statement. From above, where you ask for the age, you do your if, ever. So, if age is less than 0, print error message, output error, like that. That's the example of that. And then it keeps going on after that. So if your age wasn't less than 0, it's not an error, so you just happily go on your way. Now we really ought to do something more than just print an error and go on our happy way. We ought to loop and make them enter good data, that kind of thing. Or we ought to stop the program entirely, not just continue on our merry way, because if it's bad data, it's bad data. The bottom one we did, where we were saying you can register for the service or not, is this type. If do something, if the case is true, if age is less than or equal to 18, 80, that'd be some service. Okay. If age is less than or equal to 18, do thing 1, print okay. You can register for the service. Else, do thing 2. Now, since we say the word else, and since the word else is a keyword in our language, people wish there was an else block. And if I don't make a big deal out of pointing this out, they'll drag another one of these out and they'll put the word else in it. No, that's not the way it works. There is no else block. The else is just a line away from the decision block. But if it really bugs you, you can put the word else down in the line that's leaving it away, like that. Just double click on it and say no or no else, whatever. But trying to do it, by the book as much as possible. So there we go. That's the difference between the two. You get the idea? That's example 1, that's example 2. Here's our code. That's example 1, that's example 2. All right, how about a while loop? Our choice is equal to yes. We have to have a loop variable to loop on. While the choice is equal to, I said yes and then I typed y. Then we're going to do some work. And let's just do the circle one again. Radius is equal to input, radius of circle, question mark, end quote, in parentheses. Then convert it to a float. Now we're good to go. We can calculate the area of the circle, which is pi r squared, so 3.14159. We could import the math library and get a much more precise version of pi, times radius to the power of 2. Just reusing the example because that way you're less likely to get typos since we've already done this. Alrighty. We're going to print the area. Area of circle is, end quote, comma, area. But now we're going to ask them if they want to do it again. So, choice is equal to input repeat y/n. And down here, we're going to print a done statement, just to show that the loop is done. And I've kind of put too much white space here, and the places where I put the white space don't necessarily make sense, but I kind of grouped them together. That would be an input block. That would be a process block. That would be an output block. And that would be an input block. And that would be a decision block, and that would be another process block, a declaration, or an assignment. Okay, so there we go. I want to test to see if this works, and then I better do walkabout, because I know I'm going fast. What is your age? My age is 18. What's the radius of the circle? 20. The area of the circle is whatever. I hope that's right. Repeat. Yeah. Radius of the circle, 0. The area of that circle is 0. Surprise. The radius of the circle, -10. I'm trying to break it. The area of that circle is 314. Well, I suppose that's kind of true. If I was writing this code for reals, I would probably make it to where it didn't accept a negative radius, because that's kind of a weird idea. Now I'm tired of playing with it, so I'm going to type in no, and it says done. That's an example of a while loop. In a while loop, you set things up. You do some housekeeping, is what the book calls it. We have to declare that variable before we can check it. Because if that line wasn't there, I'm going to delete it, but I'll paste it again. Then how would it know what our choice was? Right? It would get down there and it would call that a syntax error because that variable is not found. Give us some error about, identifier. Something like, well, I can run it and find out. All right. Choice is not defined. Well, sure enough, it's not. So we have to define it first. That's why we had that. And it has to be a value that would let it go ahead and slip into the loop, right? You have to have your ID before you get into the club. You don't have the ID, you can't get into the club. So it has to be a valid ID before we even get in. This has to be a valid comparison, so we had to initialize our loop variable to something that was legit. Then we could do all this stuff, and then we update our loop variable. Because you have to have some kind of update, or else it'll be an infinite loop. Just like when I said that A is less than 10. If A was always less than 10, it would repeat forever. Okay, so that's a while loop. Anybody having syntax errors you're like?
I just had an observation. When you input a negative value, it's less than 0 and it's not greater than 18, so it's in both of these.
You are right, it does. And so, yeah, the question is if you input -0, not -0, if you input an age of less than 0, it really shouldn't do this stuff. We could fix that in one or two different ways. One way, and you can do this if it bugs you, is do an else there, and then tab this stuff over, like that. That'll fix it for you. I'm going to undo those changes. This wasn't a really good example. What I really ought to do is I ought to loop until they give me good data. And I could put that in its own module so that I could call that module anytime that I wanted to. Anybody else with typos?
That's really kind of
Very good point. All right. So the question is, I typed in y and it didn't work. That's because in this particular case you typed a lowercase y. You could fix that if you wanted to. You could make it loop on either uppercase y or lowercase y. And you notice I emphasize the word or. That's because it's a keyword that's involved. So we could add that. While choice is equal to y, or choice is equal to lowercase y. And if we wanted to get, really generous, we could let them type in yes, or choice equals yes, but then, what if they type it with an uppercase y and a lowercase, that's too many choices. There are other ways to handle that. As we go along, what we would probably do is we would change the choice variable to be uppercase, and then we would just use the first letter of it. So if they typed yes, great. If they typed yup, great. If they typed in a lowercase y or an uppercase y, it would work. Not quite there yet. All right, I think that's about enough for now. I want to hit the PowerPoint, and then we're going to come back, and we're going to flowchart some of this. So I need to do our time judiciously. Yeah, we still have time. supposedly they've done studies saying that if you have a physical textbook, you learn more from it than you do an online one. But be that as it may, we have what we have. Elements of high quality programs. I'm pretty sure that we got to this section on modularizing. I'm pretty sure we've talked about constants, right? You define pi or you define your sales rate. I see one head nod. I hope that's true. All right. We've talked about types. Two numeric types. What are the two numeric types? There's integer or just int. And what's the other one? And it's not string. That's an entirely different type. It's not numeric. Float. Integers are whole numbers. Floats have a decimal point. This language doesn't care much about the difference between them. Others, you have to go to a lot of trouble to make sure that they're treated differently. So the book is talking about those languages to some fair extent. They support type safety, meaning that if you define your variable as being an int, you better not turn around and store a float into it because they are treated differently. A string variable can hold, text. It can hold letters of the alphabet. It can hold numbers, but those are not valid numbers for doing math on until you do a conversion. That's why we always do that float parentheses, is to turn that string into valid, a valid actual numeric data form. Otherwise, it's just a series of ASCII characters, like we talked about a couple of weeks ago with hexedit. So the identifier is the variable's name. There are some rules. Most languages allow letters and digits. Ours does. Some languages allow hyphens. No, ours does. Excuse me, ours does not. No hyphens in our language. Python supports underscores. Reserved keywords are not allowed. So, since if is an important word and so are while, can't use those. One more. Cannot start with a digit. So taxes 2000 is valid, 2000 taxes is not. And remember, identifier covers both variable names and module names, so the same rules apply. And pretty much your file names ought to follow the same rules. I'm going to tack one on. No spaces. So here we go. Letters and digits. Python allows underscores, so I'm just going to combine that with this one. Letters and digits and underscores. Reserved keywords cannot be allowed, cannot start with a digit, no spaces. Those are our four rules in this language. Since the book doesn't hammer in on Python specifically, that's why I'm taking the time to write the notes. I hope you all review them occasionally. Variable names are case sensitive, and this always gets us, radius, and then at another point you'll type radius with a capital K R. Then you'll get a syntax error, and it takes you a while to spot it at first. I'm good at spotting these things, but it's a learned skill. Another thing people always do is they always type radius like that in one place. It's just a typo. Whatever. So, identifiers in every language since 1970 are case sensitive. I had some student make a remark like, well, when you started programming, they must have had punch cards. No, that's like 50s, 60s. Come on, guys. I'm not that old. Alrighty. And they should have an appropriate meaning. They should have meaning. What does that mean? I wouldn't call my two values Fred and Barney. That's dumb. I would use age and weight. Those are valid variable names. When I say valid, good variable names. Because Fred and Barney are valid. And if I was a smart aleck, I could make, you know, all my variable names really weird things because the programming language doesn't care. I could change the word age, you know, to Tony, as long as I did it everywhere, right? Don't make this change because I'm going to do it really quickly. But it works. Up to, you know, I'm not going to change them all. But if I ran it, yeah, sure enough, even though it says age here, if I type in 12, it's being stored in a variable called Tony. Works, but it's dumb. So give your variables good names. That includes excuse me, avoiding single letter variable names. So don't abbreviate too much. What do I mean by that? IR. No. Interest rate? Yes. Right? No. X? No. Or W for weight? No. Weight? Yes. Right? My exception is for loops. You're going to make a counter go from 1 to 10 so that you can read in 10 words. Don't type in the whole word counter. You could just use X or I or something like that. So avoid single letter variable names. These are not rules, these are guidelines at this point. Or too short, right? So they should have meaning. Don't abbreviate too much. Avoid single letter variable names, except for counters. Even then, maybe you want to give it. What you're trying to do is you're trying to write code that's clear and easy to read, right? So if you're writing a story, novel, and you never used anybody's names and you always use he and she, it'd be really confusing. Now maybe if the person looked at it enough, they'd be able to figure out which he was he and which she was she and stuff like that. But usually, you know, you'd want to use their names occasionally, right? You'd want to give the words meaning, make it easy to read. So when you're writing your code, you're trying to make it easy to read. That's one of the reasons why I put white spaces. It would work just as well if we deleted all this stuff, right? This would work just as well if, oh, I didn't do it as much. But anyways, you know, like that. Don't have to have these spaces. Usually when I'm typing code in for y'all to follow along, I put spaces, you know, in places like that. I didn't this time. It's all good either way. The only time in this language that space is absolutely critical is in the tabbing. And even that's not true of a lot of languages. Now, some students don't like the white space. They delete all the white space. Or they just don't type it in to begin with. They think that's clearer to read. And I can see that to some extent. But that's like writing a story and not putting a blank line between your paragraphs. It's fine, but maybe it's easier to read if you put the blank lines. So you just try to break up your code visually. Okay, end of philosophical discussion there. When you're declaring something, you can put all your declarations up at the top. Now, we didn't have any declarations in our code, really, except for that choice variable. But we could have. Let's change our code a little bit. You don't have to do all that white space stuff that I just did, but let's declare our variables. Age is equal to 0, and let's put a comment. User's age. And then let's do minimum age, and this is a constant, so I really should put it in all caps. So I'm just going to call it min age, right? Make things easier to type. Our minimum age is 18. And I'm going to add a comment that says that's a minimum. So these are our declarations. I could even, if I wanted to be thorough, put the word declaration up here. Declaration. Now, in pseudocode, you would probably do that, or at least they show that in the pseudocode, but you don't have to. In the flowchart, they do put it in one block, and you can put as many declarations in that same block as you want it to. Now, why would I define age here if I'm just going to refill it in again there? Well, mostly just because I wanted to show you a declaration. But also because in some languages you do have to declare your variables before you fill them with data. Now could also be moved to our declaration block. I'm not gonna. But I could yank choice from there, push it up there. Now since I have a constant called min age, I really ought to use it. I should change that 18 right there to be min age. So if age is greater than or equal to min age. Alrighty. I hope it still works. I may have broken it with all my changes. What's your age? 19. I'm eligible for the service. What's the radius of the circle? By coincidence, it's 19. Repeat. No. Okay, so it's still working. Why would I make this a constant? So that if I had to use that minimum age several times in the program, it'd be easy to spot, easy to read. And what if the minimum age changed? We're talking about changing the minimum age to buy guns to 21. And your program is written to use a minimum age of 18. And you didn't have it defined as a constant. You'd have to search and find everywhere in your code where it used 18 and change it to 21. Instead, if it's defined as a constant up at the top, you just change it in one place. So here's the flow chart showing declarations. They put it in a yellow block. Who cares about the color? They listed several of them. Great. You know how to put multiple things in a box. You just hit Control Enter and it goes to the next line inside the box. Then they input something. They did my answer is equal to that, and then they output the answer. So naming your variables. I do one of two ways. Either like this. Well, I'm not going to erase that example. This is called camel casing, which is a stupid term, but it's because it's got a hump in the middle. Capital letter in the middle. So hourly wage. You could also use underscores. Like this, hourly underscore wage. I think that's easier to read for students looking at the board, so I tend to do it like that most of the time. This is old school. That's like 70s and 80s style. This is newer school. Both are valid. Then there's something called Pascal casing, which if you're programming in a Pascal language, which only 10 people are anymore, that's fine. Then there's Hungarian notation. We're going to skip that. Snake casing is what they call the underscore one, and another cutesy term. Mixed case with underscores, well, that's getting kind of absurd. Kebab case got hyphens in the middle. Well, our language doesn't even support it. Just make your choice. You like camel case? Great. You like underscores? Great. And you just use those to hook up multiple words to make them easy to read because we're not allowed to use spaces. Now we know how to assign values. My answer equals my number times 2. And in the pseudocode, we tack on the word set. If you leave the word set off in your pseudocode, I'm not going to count you wrong. Initializing your variable is when at the very beginning of your program, or anywhere before you need to use it, right? Because I had to initialize that variable called choice before I could loop it. The named constant, we talked about that. Sales tax amount. Those are used to avoid what are known as magic numbers. Magic number is a sarcastic term for if you were looking at a huge, program and you went through there and you saw, if x is less than 65535. And you'd go, what in the world is 65535? I don't even, And you scroll up and down, you're trying to figure out why they were trying to limit x to being less than 65535. But then if it was rewritten to say if x is less than memory limit, and somewhere else memory limit was set to 65535, that makes sense, right? But that 65535 is a magic number. It doesn't have any meaning. Now some magic numbers are easy to spot. 3.14159, that's pi, But usually you want to avoid the magic numbers and you would want to define constants that hold them. Have we talked about PEMDAS? Parentheses, multiplication, division, stuff like that. A little bit, not at all. Alrighty, that's a veering off from doing the flow chart. So So I'm just going to put the words stop here for now. I'm going to go back to do our flow chart. Oh, let's spend 7 more minutes talking about it. Okay, so when you're doing math, A is equal to 2 times 3 plus 4. You probably remember these rules. What do you do first? You do the multiplying, right? And then you do the addition. So multiplication and division have higher precedence, higher priority than addition and subtraction. Even above that are parentheses, right? Because we could do this, we would have to do that first. And I know that y'all know this stuff. We just got to call it out and make absolutely sure. So P, parentheses. And then exponents. If we had to the power of 2 there, that would have to be the first thing that was done before anything else other than the parentheses. But in order to solve the parentheses, in this case, we would have to do that first. So exponents. So you see why they came up with PEMDAS. And the silly mnemonic, please, I didn't make this up. Please excuse my dear Aunt Sally. Helps you remember it? Great. You already know them, I'm pretty sure. Maybe the exponent hadn't been hammered in. Now in this language, there's more than one kind of divide, right? There's floor division, and then there's modulus. Please tell me we've covered modulus. Raise our hand. Yep, okay, good. So also floor division and modulus count as MD. Alrighty, so A is equal to 3 times 2 plus 1, as opposed to A is equal to 3. Well, that's dumb. 3 plus 2 times 2, as opposed to A is equal to 3 plus, or times, I'm going to move that one up there. And then let's throw in one more with an exponent. A is equal to 3 plus 2 to the power of 2 times 2. Alrighty, so what's the first one? Just eyeballing it in your head. We'll talk through it, but yeah, because 3 times 2 is 6. You did this first. You do multiplication first, and then you get 8. So 6 plus 2 is equal to 8. What's that one?
12.
Yeah, that's 12, because 3 times 4 is equal to 12. And then, yeah, 3 plus 2 times 2 is 7, so because 3 plus 4 is 7. And then, what's that one? Well, 2 squared is 4. You had to do that first because E's higher than MD. So 4, and then times another 2 is 8. And then you add on 3. That's 11. So 3 plus 4 times 2 is equal to 3 plus 8 is equal to 11. Just know how to do that because there's going to be, a question or two on the exam, making sure that you know how to do that. I don't want to belabor that point. I'm pretty sure y'all know that already from your math. If you have any questions, let me know. And I didn't tack on floor division or modulus because that's kind of extraneous to it. You just have to remember. Okay, one important point though is if you have this, A is equal to 10 minus 5 times 2 plus 4. I'm not sure if I'm coming up with a good example. Since this says A and S, that doesn't mean that A has to be done before the S's. You don't go through here and go, oh, well, I better do that plus before I do the minus. No, if it's in the same priority level, you just do them left to right. Same for multiply and divide. You don't go and do all the multiplies first before you do any of the divides. Instead, you just handle all the multiplications and divisions left to right. Hope that makes sense. That's why I arranged them vertically. The things in the vertical are, equivalent, same priority, so you just do them left to right. Okay, so we had some code here. We don't have a module in here though. We have flowcharted a module, so I'm not going to do that one again. But I would like for us to flowchart this one. It's going to have, it's going to be a pretty long one, but it's okay if it goes past the end of the page. I think we can get it done in 15 minutes. I'm going to make a new flowchart myself. Guess I could just scroll down a page. If you want a second page, just drop an item and then pull it down, and then boom, it makes a separate page. Okay, now all of our main code starts with a start. So I'm just going to tack that on there. To try to make this easier for me to handle, I'm going to take this stuff, copy it, and paste it into a comment over here on the side. You don't have to do that. Never a bad idea. But that way I don't have to keep flipping between the code, right? Alright, now that looks pretty tacky. I'm going to take the moment to spread it out. Alright. Okay, so comments we ignore. What's the first actual line of code besides the comments? Yeah, age and min age, which we said that we could put together in a declarations block. So I'm just going to draw a box down here. If I'm going to do it book style, I would actually put the word declarations, and then I'm going to hit Control Enter and do age is equal to 0, Control Enter, min underscore age equals 18. And you don't have to resize your blocks, but I always try to fit as much on the screen as possible so I don't have to scroll up and down. All right, after that we have an input statement and a conversion. I'm not going to bother making us put the conversion on the flowchart. If you did, it'd just be in another process block. But not all languages require the conversion, So I'm just going to do an input, and as we've mentioned before, inputs go in tilted rectangles. So how about just input age? If you followed the Python syntax exactly and you said age is equal to input parentheses, in parentheses, I wouldn't count you wrong. But you shouldn't make your flowchart look too much like any one language, because then somebody else programming in Java or C# or whatever is going to wonder why in the world you gave them Python code. Alrighty, so what's the first stuff after we get our age in our code? Scrolling our eyeballs down, once we have the age variable, what's next? Yeah, if age is less than 0. And we said that ifs go in what kind of block? Yep, the diamond blocks, the decision blocks. So I'm going to grab a diamond. The book doesn't put the word if in there, and if I wanted to do it book style, I would do that. But I don't consider myself entirely bound by the book's convention, so I am going to put the word if in front. For a moment, I'm going to try to make that text a monospace font. Monospace means that the spaces are all equal, and I is just as wide as an M. Makes it easy to read. Why? Because I want my indentions to stand out. If age is less than 0, I am going to jut off. And since we tab for that, I just like making my yes go to this side. We have another instructor named Terry Byers who thinks that they ought to go off to the left. That's fine. All right, I put the wrong kind of block here. Why is that the wrong kind of block? Because it should have been a print statement. So, delete. Get the right kind of block. Now, I didn't do that as a teaching lesson. I just grabbed the wrong kind. Okay, so output, I wouldn't count you off if you use the word print. Invalid age. Now, since there's no else clause here, I don't have anything jutting off to the other side. I just drop down and put a connector. Shrink my connector down, take the A out. All right. Hook back up like that. So we have handled everything up to this point, right? We are now at, I wish it was a little bit easier to edit this text once you blocked it in. Anyways. That's the point we are now. If age is greater than or equal to min. I'm going to scroll down a little bit and we're going to do this. Now since it's got an else, there's going to be lines jutting out either way. So again, this goes in a diamond. If age is greater than or equal to minimum age. If age greater than or equal to min underscore age. If that's true, we're going to print eligible. Else we're going to print not eligible. Or, you know, eligible for the service, else come back next year if we want to make it look exactly like our code. So if that's yes, we want to print eligible. So output, parentheses, not parentheses, quotes, eligible. For some reason, I don't mind writing our code in a kind of sarcastic way to keep myself entertained, but when I do the flowcharts, I'd rather make it look legit, and I haven't figured out why I have that personal preference. Alrighty, so that's the yes side. And he's going to come down here to a connector, but I'm not going to draw the connector yet because I need an else side. Else come back next year. Now, like I said, there's no block for else. It's just implied. So if I jut off this way, I can put my other message, which was output, come back next year. Now I have two branches, but you're not allowed any dead ends. Everything has to eventually work to the stop. Just like if a river dead ends, it's a really bad thing. You know, the river's supposed to join up with a larger body of water and so on. So here we go. You know, even dams have spillways to let it continue on its merry way. All right, if I was trying to get mine to fit on one page, I would move things around. I don't care. My thing not fitting on one page is a result of starting my flow chart too close to the edge. And when you do these, I don't care either. I mean, if you turn something in and it spans 20 pages because you put them all over the place, cool. As long as the arrow's going the right way, you're all good. All right, now we're at this point. We're at the while loop. We have another assignment here. Another declaration. I could move it up to the declaration block. I'm not gonna, because one reason why I say that is because I like to keep the variables defined kind of close to where we actually use them. You know, choice is kind of just used in one place. We're not going to reuse it. I could have put it up in the declarations. You'll notice that things are inconsistent, right? And that just means that you have freedom when you're writing your program to decide, do I want to define all my variables up at the top in the declarations block, or do I want to wait until I need them? Both are valid choices. You just have to figure out which one seems to make more sense in that opportunity. So I need a assignment block, which is a process. It's not a module call, so I'm not going to choose the bars. Choice is equal to, or, you know, yeah. I've already done something slightly wrong according to the book. I should have been using the word set everywhere I had an assignment. It's funny, I like to add extra words to the decisions and remove the extraneous words from the process blocks. Do it book style, that's great. Do it professor style, that's also cool. All right. So we've done the choice is equal to y. Now we want to do while choice. So this is going to be a while statement. Since this is a lot of text, I'm not going to put both cases in my while block. I'm just going to say while choice is equal to y. Otherwise, if I type in or choice equals lowercase y, you know, we're cramming a lot of stuff. And this is just kind of for visual. While choice is equal to, or equal y. You could even use the word equals. I don't recall if the book shows us using the word equals or not. All right, so since we start indenting under a while block, when do you start indenting? Anytime you had a colon on the line before. When do you have a colon? When stuff underneath it's going to have to be indented. Okay. Kind of one and the other. So after every if, after every while, in this language there's going to be a colon. Which means that after every if or every while, we're going to jut off to the side. Now we're inputting the radius. That's another input block. Input radius. After we get the radius, we calculate the radius. What shape does a calculation go in? Y'all know this.
Process.
Yeah, it goes in a process block. Come on, guys. Calculations go in a math block, process block, like that. So area is equal to 3 point, I'm just going to say pi times radius to the power of 2. See, I should have defined pi as a constant up in my declaration block. I could go and edit my code and, you know, everything to make that the case, because it is a magic number. And our code may need to be revised so that that's a more precise value for engineering purposes. All right, now we have the area, so we're on the print statement. We know that print goes into the same shape as the input. So then output the area. All right, so what's after we calculate the area? We print the area and then we get the choice. Now here's where the fact that I combined my print and my input into one statement in Python makes it a little bit more difficult to flowchart. Why do I say that? Because unless I mimic the text exactly, I don't know how to represent it. So I'm just going to go ahead and mimic the text pretty much exactly. And what do I mean by that? Because if I do input choice, I don't say what the choice is. I guess I could do it like this. Repeat, question mark, y/n. Or I could have done choice is equal to input, parentheses, quote, you know, I wouldn't have gotten you wrong for that. But I think I have to give some indication of what choice is, because otherwise, you know, if all I did is input choice, you wouldn't know what I was asking you to choose. I could have been asking you to choose your favorite color, you know, what command you want to do next. All right, and like I said, here I did it my style, but the textbook shows the line going out the other way. So I'm going to delete that line and try to draw it going the other way. But I need it. You know what? I really wish I was doing it the way that I like doing it, because it makes it really ugly. See? And then I have to drag lines over. Okay, I'm going to give up. Just know that the textbook shows it going to the outside. You're allowed to go and make it go into the inside, and if it makes it easier to do. But it's a while loop, so you always have to have a line looping back to it. Otherwise, it's not a loop, right? Just like a circle's not a circle if it never meets itself. It's just a wavy line. The book shows it going to the outside. No big deal. All right, and at this point, once the while loop is done, if I scroll back up, we would see that the last line of code is the print done message. I forgot to put a line connecting all my shapes. That's wrong. I'd count myself off a point for doing that on the assignment. So I need to just stick a print done down at the bottom. If I wanted to, I could draw a great big line, you know, going all the way down here. That'd be fine. Or if you just kind of wanted to make it kind of go off to the side, that'd also be fine. Output done. All right. And then I'm not really done. What do I have to put after that? Yeah, I have to put the end, the stop, the terminator. Here we go. All right, I'm going to zoom out just so you can kind of see the general shape of it. That's what my code will look like, because I didn't take a lot of time to, you know, format it better and stuff like that. We have some if statements. This if statement's just an if. This one's an if else. Then we got further down and we had a while loop. All right, I'm going to zoom back in. If you need a printout of this so that you can finish typing in it, that's fine. We're about done with class. I wanted to give homework, though. Let's see if the homework the other class got. Sorry, I know I need to keep it on screen, but I'll make one up. Homework. Flowchart following pseudocode. Start. Input age. While age is greater than 0, output happy birthday. Age equals age minus 1. And since I'm doing pseudocode, I'm going to try to do it the way they do it, set age equals age minus 1. So that's a while loop. Now let's input fave color. And I will post this. You don't necessarily have to type it along. If fave color equal red, print, no, output mine too. Else output, that's a good color. Now we need one last thing. Input fave song. If fave song equals, it's all about that base. No, let's do umbrella, one word. Print. Rihanna is cool. But we're not going to do an else. So then print or output done. Let me zoom there. Yeah. Okay. Like that. And then we're done. So stop. That's what the program's going to be. So we're going to have an if. We're going to have a while loop. We're going to have an if, else, and then we're just going to have an if. So slightly different than the order in which we showed them in our big flow chart. That way you can't just copy and paste and change some text. But you can draw it. Shouldn't take you more than 10-15 minutes. All right, I'll take roll based on what y'all upload. So everybody please upload something into the Dropbox that doesn't exist yet. Let's make that Dropbox. Then I'll bring the code back up. If you need to draw anything, continue drawing, or I can print it out. That'd probably be easier for you. If you want to change the colors and you want to change the umbrella to a different favorite song and whatever, feel free to be a little bit creative. Alrighty. As long as it follows the same logic. Alright, there we go. If you refresh your Dropbox, why don't I see it? Because it's in class and not a homework. All right. So I shouldn't have called it 3. I should have called it E. So upload your flowchart. Now, how do you upload your flowchart? Do you remember? What you do is you go to your flowchart and you click File, Download As. File, Download As, PDF. If we'd done a save first, it would have asked us for a name, and we get a better name than just blank diagram. So I'm going to do that. I'm going to go back up to my menu. I'm going to choose File, Save As, and I'm going to call it March 1 flowchart. Make it easy to find. And then if I do OK, then I do another Download As, File, Download As. At least it gives it a good file name when it comes down. Hopefully you can find that file and upload it. Alrighty. Any questions? I think this room is ours, so we can hang out and talk about homework, or don't see the Dropbox. That's my mistake. I don't see it hidden. Am I in the right class? Thursday, Tuesday? Is this Thursday, is it not? Yeah, it is. Okay. That would be why. Nope. Yeah, I did set it for the wrong time. That would be why. No, I didn't. I put it in the C++ class. Brilliant. Okay. Sorry, guys. I'll fix it. Its name later. I'll fix its date later. I'll fix its letter now. All right, Dropbox F. Refresh, you'll see it. Please tell me it's there. All right, good. Good deal. And if you're looking at this at home, you can go and you can get the flow chart from the daily notes. Finish it off if you didn't have time.